Okay, welcome back. Our next speaker is John Seager. He is the Vice President of Engineering, responsible for enterprise solutions at Canonical. Part of the teams that he leads are the teams that deliver Juju, and that's what he'll be speaking about today. Interestingly, also, he was part of the British Army, doing some interesting stuff there. He is a father, a husband, he loves coffee, he loves cars and motorbikes. So thank you, and help me welcome him.
Okay, are we on? I think we're on. All right, so I'm going to talk a little bit today about Juju, what Juju is, but more fundamentally why we're doing it and why I think the approach that we're taking is a little more sustainable to some other people who are solving similar problems. So firstly, I think a little bit of context. Open source has kind of become the new mainstream in a lot of technology, right? So whereas 20, 30 years ago, it was kind of this weird little thing on the side that no one really talked about, and it seeming like no one seriously really used it. Now you see kind of big companies, individuals, you see as many people, like more people than we've ever seen before, contributing their code, their applications to open source. And it's not just hobby projects, right? It's like world-class applications in just about every category of software you can think of. Think of Linux for one, but Postgres, Visual Studio Code. There's just a huge like litany of ridiculously successful open source projects. And that has kind of made software really available, except that even with all of that availability, you still have to find a way to compose that software together. Most kind of enterprise software or software that needs to be operated in production in some way doesn't normally stand alone. You're normally going to need some kind of backing database, some kind of cache, perhaps a message bus. There's a huge kind of integration problem that you have, and that's hard enough when you just do it on one single cloud, but it's borderline impossible when you're doing it across multiple clouds all at the same time. You can obviously figure out how to do all these things in isolation, configure your Grafana to talk to this and your Prometheus to that, but every single application that you integrate with is going to have kind of a different set of patterns, configuration file formats, perhaps there are differences per cloud. And then even if you've done that, you then have to somehow support all of that and operate it, right? Like you have to take the automation that you wrote and maintain it. You need to keep dependencies up to date as new formats emerge, like OpenTelemetry, for example. You have to figure out how to evolve your configuration and then kind of roll it out over time. Let alone just thinking about your responsibilities to kind of patch your infrastructure and keep things up to date. So you might be wondering, well, isn't this already solved? Like there's all these big hitters on the screen that I've heard from: Ansible, Terraform, Puppet, Chef, Helm, right? Like all of these popular projects that you kind of see hanging around in Git repositories, right? You'll see Helm charts and Ansible playbooks and Terraform declarations everywhere. And I would say it's kind of a solved project, right? Like what all of these guys do really well is deployment. Right, like standing up a Kate's pod with a couple of containers in it, or deploying a virtual machine, creating a VPC. Like you can do that stuff, but then what about backing up your apps, right? Let's say you've got 5 apps in production. You have to figure out a backup strategy for all of them. They're all going to behave completely differently. They're going to have different storage backends. How do you collect metrics from each of those applications? What are the important metrics? How do you build dashboards? You know, and how do you then maintain all of this stuff, right? Like one thing that's almost certainly true about all of these things is that over time your Ansible playbooks will rot, your Terraform kind of declarations will rot because AWS update their APIs, they change how things are provisioned, they change the SKUs. And so while some of these are very, very competent tools, of which I'm very supportive, we have a Terraform provider for Juju, they don't really solve the whole problem, in my opinion. Or at least not without a significant amount of toil and kind of wraparound alongside. And so, as I was kind of saying, we've got all this open source application code, but that hasn't really helped enterprises actually adopt and use that code, right? Like without a solid understanding of how to operate the applications, how to back them up, how to patch them, there's often just too much perceived risk, particularly in your kind of more traditional enterprises. And so they end up not really being able to take advantage of it. And so what we really need to do is get to a point where people aren't just open sourcing their applications, but they actually open source the operations code too. And what is operations code? Like what is it we'd be looking for people to actually open source there? Well, it's all of the domain knowledge that the people who wrote that application have about how to drive a Postgres in production, right? How to set up a set of Prometheus scrapers, how to whatever the application is, the people who wrote it or the people that built it are likely to understand how best to configure that in various situations. And if you can kind of condense all of that down into some clean, well-tested code and share that, then the chances of businesses and individuals being able to actually wield your software in production go up quite dramatically. And so that's kind of what we're trying to do with charmed operators, right? Charmed operators are packaged ops code, simply, right? It's packaged ops code with a mechanism for distribution through a store, and then a kind of lifecycle manager, which is Juju, to kind of pick them up and deploy them wherever it is you need them. So I guess I'm presenting Juju as a platform for you to deploy any application at any scale on any platform or substrate, any architecture, right? Like you can, in theory, and in many cases in practice, rely on Juju to do all of the things we've just been speaking about alongside the kind of ecosystem of charmed operators. And we're going to kind of spend a bit of time trying to understand what that means. That's interesting. There's supposed to be little Juju symbols along that line, but I don't know where they've gone. I can see them on there and not on there. But anyway, so at deploy time then, what does Juju do? Well, it behaves just quite similarly to Ansible or Terraform, right? It's going to go and pluck you a VM from OpenStack or from AWS, or it's going to deploy a K8s pod with a couple of containers in it. And it's going to maybe run some scripts or some kind of predefined actions to install packages, write configuration files, start and stop services, whatever it might be, whatever is kind of idiomatic on the platform that you're on. And critically, all of that integration is maintained by the Juju team, right? So there's 22 headcount or so at Canonical, full-time people to work on Juju, making sure that the latest and greatest AWS APIs are supported or Azure APIs are supported. But the really important bit, or the really interesting bit, is integration here, right? And so Juju provides this kind of rich language for joining applications together and sharing information between them, which we know as relations. And fundamentally, because we're open sourcing all of the operations code, you also get to see exactly what's going backwards and forwards between these apps, and therefore what you would need to do to make them talk together. And on the operations front, there's another kind of rich set of languages for running actions at day 2, which might be triggering a backup or upgrading a package or kind of refreshing the thing from the store. There's all this kind of stuff that you might want to do, 2 days, 10 days, 5,000 days after deploying your thing. That's kind of all built into Juju. So when we talk about software lifecycle, what are the sorts of things we're talking about? Well, at deploy time, you're talking about installation of packages and software. You're talking about configuration of that. You may be talking about upgrade of operating system components. You may be talking about deploying at some particular scale. As we talk about integrations, well, you've got databases, observability tools, caches, event queues, like whatever it is. And in operations, there's some kind of contrived examples up there of the sorts of things you can do. But really, it's anything that you might want to do after the fact where you've initially deployed the software, right? So another really interesting feature about Juju is kind of how flexible it is. So in this example here, there's 4 kind of scenarios, right? And you can use Juju to build any of these. So on the far left, you have AWS, on top of which you could deploy charmed Kubernetes, composed of a bunch of AWS VMs. And on top of that, you could deploy Prometheus, Postgres, and Kafka, which is a sort of contrived, somewhat unrealistic stack. But you can deploy that on top of the Kubernetes that you just deployed on top of AWS. You could also start with a bare metal deployment, right? You start with MAS, you put OpenStack on top of MAS, then you use the same Juju controller to put Kubernetes on top of that, and then you use the same Juju controller to deploy your apps on top of the Kubernetes. Or you could just go straight to Azure, for example, and deploy these apps as VMs directly on Azure. Or you could go to any kind of conformant CNCF Kubernetes and deploy the app straight on top of that. And the interesting thing here is you can use one controller for each of these stacks, or you can use one controller for all of them combined, or you can have a whole bunch of controllers up and down the stack depending on how you break down your business, how you kind of break down responsibilities for who has to support things, deploy things, configure things. It also gets probably the closest I've seen to the argument that you can write your code once and deploy it anywhere. Terraform famously came out with this, right? They said, well, it's easy. Just like write all of your infrastructure down as Terraform code, commit it into version control, you can put it anywhere. Except what they really meant is you can put it where you meant to put it the first time. But if you need to move to Azure, you get to start again, right? And then if you want to move to Google Cloud, you start again. Because all of the services are constantly changing and the SKUs are different enough that there's no real universal language between the major public clouds and private clouds, right? With Juju, that's actually not the case. With Juju, we have a Postgres operator which you can deploy on all of the major public clouds, and there's one extra variant for Kubernetes which shares a whole bunch of code. And so you do actually become sort of empowered to just pick the cloud provider which has the best resources for your particular workload. Perhaps it's the best cost breakdown. Perhaps there's a better support relationship with your organization and that changes over time. Whatever it is, you can just take whichever workload you had deployed and move it to any of the supported clouds. And provided the charmers are doing their job properly, then you should have all of the facility you need to move data between clouds and essentially move from one provider to the other without having to re-engineer your entire infrastructure, right? It's fundamentally possible for you to pick up the exact same code and drop it on a different cloud. It also, alongside the kind of basic integrations that you can do, so you say you've got two things on AWS, a Postgres and some web application, well, you can make those things talk, but you can also do it across cloud, and that's across private cloud and public cloud. One of the things that we don't do right now is actually establish the connectivity for you, so there's a kind of a bit of an assumption there that you'll need some connectivity between your AWS tenant and your Kubernetes cluster on-prem, but once you have that, the relation system works fundamentally exactly the same. So if you want to run your database on bare metal in your data center, but you want to be able to scale your front end out to level ridiculous on Kubernetes on AWS somewhere, you can totally do that. And if you want to change your mind down the line, that's kind of also fine. And we've got a way now to distribute these kind of relations as little tiny libraries that anyone can put in their code, right? So as the ecosystem starts to grow out and more people are contributing to things like MySQL and Postgres and Redis and Grafana, the toil for individual businesses to then charm their applications and make use of those things is really, really low. You're talking maybe 50 to 100 lines of Python to basically stand up an application. You go and grab a library because you need to speak to MySQL, add a couple of lines into your charm code, and then it can speak to MySQL anywhere Juju understands MySQL, which means you can kind of empower your developers, your users, to be anywhere they need to be. And a recent example of this was with Charmed Magma, which is a project that was originally started by Facebook for building 5G core networks. It's comprised of 50 or so microservices in total, and their documentation and all of their automation worked just great on AWS. Like, you could deploy the thing on EKS, no problem, but there was absolutely no mention of how to do it any other way. We've written some charms for that in about 8 months in total, and now you can put it on any of the public clouds you want, or you can just host it in your data center. And it's all the same packages wherever you do that, right? So Juju kind of has allowed projects like Magma and will allow other projects to kind of diversify their audience quite dramatically. So we are slowly building out a catalog of what I think are pretty great applications. It's almost impossible that there isn't going to be an application up there that you don't recognize, if not more. And to me, these are kind of foundational pieces, right? There are going to be so many applications that require MySQL, that require Postgres, Redis, OpenSearch, Grafana, right? These are kind of like table stakes things that you're going to need. If you think about a public cloud with things like Cosmos DB and Amazon RDS, these are all the reason Amazon has been so successful there is because everybody needs a database for their thing, right? And so Canonical has committed to essentially building out teams for building and maintaining these foundational pieces completely in the open. It's open source, so other people can contribute and add features and changes if they wish. But fundamentally, the building blocks are all there for people to go out and deploy their own big, complicated distributed systems in whichever manner they want. And I think a general principle when building charms is to think about building charms that are really, really great on their own, but actually better when composed with other things, right? That's kind of the whole problem we're trying to solve. It's not about deploying individual applications. It's about composing them, to build up stacks. And so if you think about some of the products that we are investing in, Kubeflow, for example, is 35-something microservices on Kubernetes. Our observability stack composes things like Grafana, Loki, Prometheus, Alert Manager, and Magma, I already talked about, is for building 5G core networks. These are essentially bundles that take the task that was kind of spend an hour, spend 2 hours, spend 5 days, trawling through documentation, trying to troubleshoot this thing on this one particular cloud to get your deployment working, only to realize that something fell over and you have to start again on a different cloud and you don't know how to do it over there now. All of that simplified in this case to Juju deploy Kubeflow or Juju deploy Magma, wherever it is that you've got a Kubernetes or some sort of infrastructure provider. And that's actually kind of just the beginning of this story. So bundles are what we have now. Things are slowly kind of evolving towards a thing called stacks, which are kind of a nicer abstraction for managing collections of software and kind of more complex software. And I'll cover that a little bit later on in my talk about kind of development work that's going to happen in Juju over the next couple of years. So I would say hopefully obviously, but all of this is open source, so you can get the code for Juju on GitHub if you're brave enough. It's a big old beast. There's also Pebble, which is this kind of tiny little init system that has been written specifically for this use case, for managing workloads on Kubernetes. It's kind of our little superpower for how we choose to drive applications on Kubernetes. The Charm Hub itself is open source. You can kind of head over to the Charm Hub and see all the charms we have available in the catalog. It kind of presents the information about configuration and day 2 actions and documentation all in one place. And then we have the operator framework, which is our kind of developer-facing toolkit for actually building charms. So if you want to write a charm for MySQL or for whatever it is, you would use the operator framework, which is a kind of nice, tight Python library that is kind of based on the event model. So essentially, Juju will fire events to your application at various times in its life, and you essentially attach callbacks to that and do whatever it is you need to do with your application. So all of that is on GitHub. It's all there for you to see. We have increasingly got quite a nice community presence. So the Charm Hub, as I mentioned, is the store, but it's also host to a discourse forum. So that's where you can interact with the various store maintainers for maintenance done on your listings on Charm Hub, but also just asking for advice, interacting with the various Juju developers, a good number of which are sat in this room. And then if kind of a more real-time chat is your thing, then we have a Mattermost instance, which anyone can sign up to. And most of that team and most of our Charm teams are in that instance all of the time, right? So if you have questions about charming, questions about how to wield some of our other charms, database charms, etc., troubleshooting, then people are there to be on hand and also kind of guide you towards your own charming efforts. We also have a public roadmap. It's probably a couple of days out of date. We've just done a bunch of planning, but I'll get on that over the next few days. And that's how you can track upcoming work on Pebble, on Juju, on the operator framework, on a few other things. And it's kind of a distillation of our internal roadmap. And because it's on Trello, if you wish, you can kind of comment on it, ask us questions, vote for things, etc. And that kind of all gets taken into consideration as we go through the various rounds of planning. That is all I had for the basic introduction to Juju and model-driven operations. Is a bit of a canter through, but we've got a little bit of time for questions if anybody has any. Ideally, those people who don't work in the Juju team. So yeah, thanks very much.
Thank you, John. Okay, do we have some questions for John?
Easy.
Hello.
Hey.
My question is, I've been using UE for quite a while, and I get the feeling sometimes that it gets more and more Kubernetes focused somehow. Does machine charms have a future?
Yeah, so machine charms absolutely have a future. They're not going away. It's definitely true that there's been more investment in Kubernetes over the last couple of years because broadly in the world, there has been more investment in Kubernetes in the last couple of years, and if we ignore that, then we kind of eliminate a huge part of the market. One of the things that I'm quite excited about is taking some of the work that we've done there, so integrating Pebble and kind of the way that we think about modeling charms, and bringing that to the machine world. So I'm hoping that we'll get to a point where we have these sort of universal charms, and universal charms will potentially be OCI image-based, so when you deploy to a machine, what you're actually getting is a couple of OCI containers stood up on containerd, sort of behaving in the same way. That said, the kind of hook tools in Juju aren't going anywhere, so like first-class machine charms, as you know them today, are not going away. There's absolutely no plans to stop that, but it will give us an opportunity for people who have invested in container-based charms to also deploy them in kind of bare metal environments and that kind of thing.
Yeah, great, thank you. Because we love machine charms.
Okay, do we have more questions?
Really nice talk. Thanks for that. It's really exciting to see the integration and kind of the growth around Kubernetes and how Juju service orchestration kind of fits on top of that. How did your team develop these technologies, like let's say the mini Kubernetes execution utility, Pebble? Where did this come from? How did these things come about?
So Pebble's an interesting example, right, of why Juju development can be hard, right? So one of the things that the Juju team, I think, does quite a good job of, and has historically done quite a good job of, is we make this promise, right, that everything that you can do on AWS, you can do on bare metal, you can do on K8s, you can do on Azure, you can do on whatever it is. And that means there's kind of a responsibility upon us to only build abstractions into Juju that make sense in all those places, which is why support in some places might seem a bit patchy, right? So there'll be no doubt people in the room who could jump up and down and say, but you haven't given me daemon sets yet on Kubernetes. And the answer is no, we haven't yet given people daemon sets natively, because we need to find a way to kind of convey that intent in all of the different environments that we work in, right? So Pebble is an example of that. Pebble was a way of us allowing people the freedom to deploy whatever OCI images they wanted using Juju on Kubernetes, but maintain the kind of same mental model that they had about how charms worked and how to reason about them, right? So it was actually the kind of second iteration of Kubernetes support when we got there, but I think it has led to a much more consistent view for people who, for example, have been using Juju for kind of several years. The way that we now model charms and think about charms on Kubernetes should feel very familiar, right? Like there's not a lot of difference. So yes, I think that's a long-winded way of saying it's all about trying to achieve that consistency so that we can actually keep that promise of portability across the different clouds and substrates and that kind of thing.
That's really exciting. Thank you.
Okay. One more question. If you have a question, you can always raise your hand up early, then we'll just bring the mic to you earlier.
Okay, so Juju API access. RESTful API is available now, or?
There isn't a RESTful API. The Juju has this like JSON RPC over WebSockets game going on. There is a Python client library called Python libjuju, which is pretty well developed. There's a whole bunch of charm teams that use that all day, every day for testing their stuff. Typically, or traditionally, I'd say we've done a kind of less than excellent job of keeping the Go kind of library code decoupled from the CLI, but there's been an ongoing effort in the last cycle and in the next 6 months to kind of pull that code out and kind of untangle it from the CLI code into something that resembles kind of like a Go libjuju. If you don't want to use Python and you don't want to use Go, there is also kind of an API like schema that gets published with every release. And I think the general kind of Juju API will be a topic of discussion in the future, but there's a bunch of other really big stuff we're working on at the moment that I don't want to kind of tackle at the same time as changing how the API works, if that makes sense.
And is the Go library still using the WebSocket? Because what we found is the WebSocket, if it gets broken, then the whole API command is then orphaned. And
it is still using WebSockets, yes. If you've got questions about that, there's like half of the Juju team in the front couple of rows who'll be able to help you out.
Employee of Grafana Labs, so it's really cool to see you packaging a Grafana bundle. I'll definitely tell the team, and I'm sure they'll be really excited. I don't know if you work with anyone at the company, but yeah, I'll pass that on. I'm sure they'll love that. Just for information, we use JSON it to render Kubernetes manifests and then deploy those with Flux. So my question's kind of related to that. What kind of do you support any as code workflows with Juju? So is it possible for us, for the room, is it possible for us to write down a kind of our desired state and have that rendered through Juju into our, let's say, Kubernetes clusters, but it could be anything?
Yeah, so there's a couple of different ways you can achieve this. So Juju doesn't necessarily fit into your traditional, like, all declarative, like, I want a JSON file that exactly represents state. And I think we would be kind of degrading some of its value if we went too far down that route, because kind of the whole point is an acknowledgement that things will change over time, right? That's what operating software is about. That said, we have got a Terraform provider for Juju now, which, and the whole point of that is precisely to enable this kind of workflow, right? So the Terraform provider can create models, deploy charms, config charms, create relations, create cross-model relations, and it's clever enough to be able to, like, when Terraform does its state reconciliation each time you plan, like, it can go and query the Juju API and figure out what the differences are and allow you to make choices. So that's probably the closest we've got, and I think the thinking about that and kind of the development of that would enable us to go and do things like Pulumi integrations, for example, if people desperately wanted to write ops code with JavaScript or something weird. But yes, and yes, the Grafana folks sort of do know what we're up to. Our observability team lead is an ex-Grafana employee too, so there's quite nice links there.
Okay, do you have any more questions? All right. Thank you again, John.
Cool, thanks very much.